So now let's prove the last part of Theorem 1014. What happens when we have a circle that is intersected by two secants, where the secants meet in an external point? How can we describe the angle? Let's say this is point C. Let's talk about the angle little c. How can we express the angle little c in terms of intercepted arcs? Well, once again, let's choose some points and name them. Let me call this point A, and let me call this point B, just to give some names here. Let me also draw some line segments in that we can draw in if we wish to. Let's draw in this line segment AB. Let me call this angle that's formed as a result angle A, which would make this arc over here have a measure of 2A, because A would be an intercepted angle. That would have twice the measurement. And let's call this angle down here angle B. That would then give this arc, let's give this a name D just as a reference point there. That would give this arc AD a size, a measure of 2 times B, since B is an inscribed angle that's intercepting the arc AD. The measure of arc AD has to be twice that of the angle. So far we've got ourselves a bunch of lines, a bunch of line segments, and a bunch of measures. But remember, it's C that we're looking for. We're looking for the measure of that angle C. So why don't we redraw this triangle here, this very narrow triangle, underneath, so we can take a closer look at it. Okay, so what we've had so far is that this is A. We also have this is C. And once again, we notice that this angle ABC is supplementary to angle B. So ABC is 180 minus B. So we can draw in for the angle over here 180 minus B. So we have once again, by the sum of angles of a triangle equaling 180, that C plus 180 minus B plus A has to equal to 180. We can subtract 180 from both sides. That gives us C minus B plus A equals 0. We can add B to both sides, thereby coming up with the equation C plus A equals B. And now we can subtract A from both sides. That gives us C equals B minus A. Okay, so once again, we come up with a nice expression for C, the angle external to the circle that we're looking for. C equals B minus A. But notice, C is intercepting the arc AD as well as intercepting this arc here, which we can call BE. Let me name this point E just for reference. So it's intercepting AD and EB. The measure of arc AD is 2B. The measure of BE is 2A. So we can say that if we took half of this difference, 2B minus 2A divided by 2, we would come out with B minus A. But B minus A is the measure of angle C. So what we've basically proven is Theorem 1014 for the case of two secants, which would be that the measure of angle C is equal to 1/2 the difference of the measure of arc AD minus the measure of arc EB. And this concludes the proof of Theorem 1014.